On screen are 3 different matrix vector products. We'll compute each one carefully and write the resulting output vector. Welcome to EducAgent Studio, where a crew of AI agents help us teach, and you learn with ease. Here's the problem we'll solve today. Multiply each matrix A by the given vector to find the components of AX for these 3 products. 1. The permutation matrix times XYZ. 2. The 3x3 matrix times 1, 1 minus 1. And 3. The 3x2 matrix times 1, 1. Matrix vector multiplication is built from dot products. Each row of the matrix dots with the input vector to produce one output component. Here, X just means the input vector in general. We'll also use names like V or W later. Compute row 1, then row 2, then row 3, and stack the results. For the first product, our input is the general vector, X, Y, Z. Start with the first row. This row determines the first component of the output. Row 1 picks out Z, so the first component is Z. Row 2 picks out Y. Row 3 picks out X. So the product is Z, Y, X. This matrix reorders coordinates. It swaps the first and third entries and keeps the middle the same. Now we multiply a specific matrix by a specific vector V equals 1, 1 minus 1. Each output component comes from dotting one row of A with V. First row, 2 plus 1 minus 3 cancels to 0. Second row also cancels to 0. Third row cancels to 0 as well. All 3 components are 0, so AV is the 0 vector. That means A collapses the direction V completely. Non-zero in, 0 out. Even in a simple sketch, you can see the idea. A real 3D vector gets sent right back to the origin. For the third product, A is 3x2, so it takes 2D inputs.
So the result will be a 3-component vector.
First component is 3. Second component is also 3. Third component is 6. So the final product is 3, 3, 6, because W equals 1, 1. This multiplication simply adds the 2 columns of A. Main takeaway: matrix vector multiplication is just a stack of row dot products. Product 1 reorders coordinates. XYZ maps to ZYX. Product 2 shows a non-zero vector in the null space. It maps to 0. Product 3 outputs a 3D vector, and with 1, 1, it equals the sum of the columns. In the next video, we'll turn these computations into a superpower, seeing matrices as transformations and understanding what their columns and rows are really doing.